this way. Your job's a joke, you're broke, your love life's DOA. It's like you're always stuck in second gear, when it hasn't been your day, your week, your month, or even your year. But I'll be there for you when the rain starts to pour. I'll be there for you, 'cause you're there for me too.
Hello, and welcome to our video. In this video, we will be showing you the proper techniques and procedures needed for a successful spectrophotometry experiment. First, we must fill our cuvettes with our prepared dilutions. We are using a plastic pipette to transfer the solutions into the cuvette up to the marked lines. We had 3 diluted solutions and a blank filled with water. By scanning across all wavelengths, the spectrophotometer can produce both quantitative and qualitative data. Qualitatively, we can observe the graph produced by the spectrophotometer to see where the peak absorbance lies in relation to a certain wavelength. Quantitatively, we are able to use this graph and measure that certain wavelength in nanometers that produce the maximum absorbance. This optimal wavelength is called the lambda max. We can then use this to effectively scan the rest of our diluted solutions. Joke break. A photon checks into the hotel and is asked if he needs any help with his luggage. He says, "No, I'm traveling light." Anyways, first we need to zero the spectrophotometer using the blank. We made sure to wipe the arrow sides of the cuvette using the chem wipe and placing the cuvette inside the spectrophotometer with the clean sides in the beam pointing left and right. Don't forget to close it before scanning. We then went to the computer and pressed 0. Here we are confirming from the screen that the spectrophotometer has been zeroed out. After zeroing, we then began scanning the dilutions. Using the same procedure as before, we wiped the 2 sides and placed it into the spectrophotometer and closed the door. We then clicked on start and waited for the absorbance to be measured. We recorded this number in our lab notebook and took out the cuvette and closed the door. The relationship between absorbance and concentration can be represented through the Beer-Lambert law with the equation A equals E times L times C, where A is the absorbance, E is the molar coefficient, and L is the light path length, and C is the concentration of the solution. We are able to determine the absorbance through the spectrophotometer. Using the graph created by the relationship between absorbance and concentration, you can find the molar coefficient from the slope. The life path length would be 1 centimeter, which is the length of the cuvette. With these numbers, we can easily solve for the concentration of the solution. With these absorbances and concentrations, we are able to observe a direct relationship between the two. As concentration increases, so does absorbance. If you do not zero out the spectrophotometer with the blank, then the measured absorbance value will be more or less than it actually is. This could result in a different observed relationship. And after a long, hard day of working in the lab, we cleaned up our lab area like the good kids we are. Thanks for watching our video. We wish we can add more chemistry jokes, but we only add them periodically. And last but not least, go Vols!